but it just doesn't seem to be working the way an air conditioner should. That's what I meant. Yeah, well, but it doesn't. It's not blowing at all. But they've definitely turned it on downstairs because I got them to double check. But all right, so this is my point. That's when I said it's not blowing. Yes, we have already started. Yeah. And so you calling out it's not even blowing was really cool. All right, so we're going to solve this one. 2 sine squared x plus sine x minus 1 equals 0. Now remember, these are basically equations reducing to quadratics. So if you have a look at that, we can start using our fine feather and furry friend substitution to make it look much more like a quadratic. So I don't know, last time we did this, we used a boat. This time we're not going to use a boat. We're going to actually use cats. We're going to use cats. We're not doing cats because I can't draw cats. I saw a funny text I thought was amusing. Just one person to another. So, when you're 50, do you reckon you'll have more cats or chins? Cats. It's like, all right, I'll go walking with you. I don't want to be the fat one or the cat one. All right. So what are we going to substitute? Let's do a substitution so that we can make this more like a quadratic. K. Can I use something other than K? Because my K's look crap. Okay, let's use U. So we're going to let U equal what? Sine x. Excellent. Sine x. Therefore, we've got, or not therefore then, 2u squared plus u minus 1 equals Europa. So we've now got something that looks much more like a quadratic, yeah? Now you need to factorise that. What are you going to get? Sorry? Cool. What are we going to have in the front? Huh? U. We're using U. 2U. U. Yeah? You keep saying K. Whatever floats your boat. All right. Yeah, true, we did. We've used boats. So, what are my two answers for U? Or K? Nick? What are my answers for K? Okay, so U equals minus 1 or a half. Okay. Yeah, okay. Nick wants to use K, and we're going to let him, because otherwise he gets upset and curls into a corner and cries. And I'm sick of having to mop up his tears. If I could just wring out the rag into my glass, I could drink the tears of my fallen enemies. Love mopping carpet. Doesn't surprise me. All right. So now the thing is, we've got that. We've got our answers for U, but U is actually equal to sine x. Would you agree? Because that's what we did. U equals sine x. Therefore, sine x equals minus 1 and a half. Not minus 1 and a half. Minus 1 and a half. Also a half is probably a better one. You happy with that? All right, so now we've got to have a look at, I'll just draw a little bit of a line there. When sine x equals a half, where are our solutions? Now you get to do your 4 letters. Yep. ASTC. So when it's a half, what quadrants is it in? Well, sine x is equals to positive half. So we're in quadrants 1 and 2. Yeah? So we're in those two quadrants, correct? Which means that we know our angle is going to be between 0 and 180. Yeah? Because we're in that area there. Cool. All right. So what are the values that we can get? A half. Sine x equals a half. So what values of x can we get positive a half for? Yeah, you could draw the sine graph, or you could draw the triangles, or you could look at your formula sheet. Because remember, this is given on your formula sheet. The exact ratios are given. Yeah, you did it. It's important. I honestly believe it's important that you remember the triangles, the 45s, the 60s and 30s. I think it's important that you know them because it means you don't have to look it up. Okay? But having said that, it is on your formula sheet. So if you can't remember it, it's important that you remember that there is exact ratios using those triangles, because at least then you will look at the formula sheet. Okay? So having a look at that, what angles? Because the other thing is you've got to remember that this will only give you the acute angles. It'll give you the equivalent acute angles. It won't give you the obtuse angles. And we've already worked out that it's going to appear in both those quadrants. Yeah? So we have to use both those quadrants. We can't just use the acute angle, which would be in the first quadrant, because that would only give us half the answer. So what are my angles? What is it? 30 and 150. Yeah? So I'll just use a red pen to draw 30 degrees. And then it's over that way, but that's 30 degrees back there, which means that whole angle is 150. Cool? A half would also be at 210. It would also be at minus 30. But they'd actually be negatives. Okay? But 30 above and below the horizontal. You all good with that? I'm glad that made lots of sense to you. So yeah, you're at 30 degrees and you're at 180 minus 30 degrees, which is 150. So there are your two answers. Sorry? 30, because sine of 30 degrees is a half. No, we haven't got different answers yet. We're about to do, last time we did sine is, we did sine x equals minus 1. We haven't done that one yet. No, it ain't. We didn't get to that. I hadn't written that up. Or if I had, I won't publish that last video because I was wrong. I don't want to be wrong on video. It's bad enough I'm wrong in real life. I won't be able to publish the boat. I'll just delete that last part. I can truncate it. Did we? Did we get... Yeah. What was one? Yeah, no, we hadn't got to it. No, you told me to draw sine graph and then no, 45, like none of them. Like the 45 degrees is 1 over root 2. I'm pretty sure you did. And this is awesome because you're wrong and I'm right. No. Did you go into one of the other teachers' classes? Because the other teachers are dumb, man. Seriously. Yeah, I did. I drew the sine graph and showed where it hits 100. Oh no. We marked on the graph where it's 45 degrees, but it's 1 over root 2. It's not a half. Anyway, we'll get to it. So you're happy with that bit anyway? Kind of. What's to be unhappy about? We're just using the exact ratios. The 60-30 triangle. Sigh. Don't make me go back over this. Thank you. The other one is sine x equals minus 1. Now, the ASTC doesn't really help us. We know it's going to be somewhere in the bottom, somewhere between 180 and 360. But it doesn't actually help us because if you, when you work it out, 270 is, sine equals -1 actually appears at one of the axes. So I'm just going to draw the graph very quickly, and this is kind of what we were doing. That's -1. That's +1. That's 0. Now what we talked about is when it goes from the start here at 0 over to that point, how many degrees have we gone? We've gone 360. So that's 360 right there. 360. So this halfway point would be 180. Cool. And then that point just here would be at 90 because it's halfway between 0 and 180. And then this point would be 270. So we're looking for the time, the only time, and this is the thing, there's only one time that sine of x equals -1. It's at that point there, which is 270 degrees. Cool? All the other ones, or almost all the other ones, have sort of 2 points. Okay? If we looked at a half occurs there, and that's those 2 positive ones that we just got. And if you have a look, that's at 30 and 150. And then a half also, or minus a half, actually occurs down here. There and there. But 270, 180, 90, and 360 only really occur once. Cool? Sorry, that's wrong. 0 and 1 and -1 only occur once. Yeah, so 270. Cool. Everyone happy with that so far? All right, so what have we actually got? We actually have the solutions. I don't know why I'm using that grey one. You can't actually read it very well. Therefore, you kept saying ASTC last time. Sorry? Yeah. It's a start. So what do we get? 30, 150. That's what I wrote. All right. Is everyone happy with that?